All right, welcome back to exponents. We're going to today look at the learning target. I can convert negative exponents to positive exponents. And so you may not have seen a negative exponent ever before. So if you haven't, this is what a negative exponent may look like. So let's say I have 2x squared. This is a positive exponent. If I were working with a negative exponent, I might have a number like let's say 3y to the negative 2. Notice how our negative exponent is right here. All right, so that looks a little terrifying, I know, and fear not, because we're going to learn how to deal with these today. So when we're working with negative exponents, a good way to kind of approach them is to think of, first of all, what do we do when we have positive exponents? And so with a positive exponent, we know that it's telling me to multiply a certain number of times. And so here I would be multiplying 10 by 10 by 10, or 1,000. 10 to the power 3 would equal 1,000. If I have 10 squared, that's 10 times 10. That's equal to 100. If I have 10 to the power of 1, I'm not multiplying 10 by anything. It's 10. 10 to the power 0, the zero power law tells us that anything to the power 0 is equal to 1. Now, 10 to the negative 1, if I were to plug this into my calculator, 10 to the power of negative 1, what would that look like? Well, let's just think about what that would look like. 10 to the power negative 1 gives me 0.1 or 0.1. Okay, 0.1. Well, what does 10 to the negative 2 give me? Well, 10 to the power of negative 2 is equal to 0.01. Or 0.01. And I wonder if 10 to the power negative 3 is equal to 0.001. Well, let's see. 10 to the power of negative 3 is equal to 0.001. Well, I know that I can also write these as fractions. So remember, you can pause the video at any time to get the notes. But I could write all of these as fractions as well. If I were to do that, 1,000 could be written as 1,000 over 1. 100 could be written as 100 over 1. 10 could be written as 10 over 1. 1 could be 1 over 1. 0.1 could be written as 1 over 10. And 0.01 could be written as 1 over 100. And 0.001 could be written as 1 over 1,000. Interesting. All right. So let's keep this in mind, how these could all be written. And let's look at a couple examples. First example we're going to look at does not involve a negative exponent. So if I were to solve 3 squared equals x, and I want to get my value of x, then I know that 3 squared is equal to 3 times 3. 3 times 3 I know is equal to 9. So 3 squared, therefore, is equal to 9. Just a warm up. So let's say we change our scenario a little bit here. Instead of 3 squared, let's say we have 3 to the power of negative 2 is equal to y. Well, all we need to do to determine what 3 to the negative 2 is we need to remember that this negative, especially when we looked at the previous examples with my tens, did not make the whole value negative, right? Just like 3 to the negative 2 will not make this value negative. Now, when you're working with negative exponents, what this tells you is that in order to make this positive, a negative exponent on the numerator, or 2 over 1, would be a positive exponent on a denominator if I put it under 1. And so in order to rewrite this 3 to the negative 2 to make my exponent positive, what we need to do is write it like this. 1 over 3 squared equals y. And that's the same thing as 3 to the negative 2. And so 3 to the power of negative 2 is equal to 1 over 3 to the positive 2, which equals 1 over 3 squared, we know is 3 times 3 is equal to y, or 1 over 9 equals y. Now, as you write this down, I realize that you might be a little confused at first, and don't worry, that's completely normal. What we're going to do now is we're going to flip back to this list we made. Now, these were positive exponents to begin with, and so we're not going to touch those, but over here, I want us to think about if we were to express these numbers down here, I'm just going to rewrite them in a different color. I'm going to rewrite them in green. So if I had 10, 1 over 10, remember, 1 over 100, and 1 over 1,000. How would I write these as exponents with a base of 10? Well, with this first one, so how would I rewrite this first one as an exponent of a base of 10? I could rewrite this as 1 over 10 to the power of 1. 1 over 100 could be written as 1 over 10 squared. I know that 10 squared is equal to 100. And last, 1 over 1,000 can be written as 1 over 10 cubed. So if we look at how I've written these, all three of these can be expressed as decimals, but they can also be expressed as negative exponents. Now, when we're working with exponents, we don't want to leave them negative. We want to work with positive exponents. And so let's look at a few more examples as to how we go about solving this and what the questions are going to look like that you're going to be working with. So, solve xy to the power of negative 2. Now, we want to write this with positive exponents. So, remember, this is x times y to the power of negative 2. If we, with these types of questions, we're going to be utilizing all the different exponent laws we've been looking at. So the first thing we got to think about is what exponent law needs to be utilized here. Well, here we have a power of a power law. We have two bases that are different, x and y, and we have an exponent outside of my brackets, which means this negative 2 has to be distributed into both the x and the y. So when I do that, this becomes x to the power of negative 2, y to the power of negative 2. Now I can flip my exponents, making them positive by putting them under 1. 1 over x squared times y squared. And this would be my final answer. So note the first thing I did was I used my power of a product law. I distributed my negative 2 into both the x and the y because there is a base of, an exponent of 1 on the x and the y. So 1 times negative 2 is x to the negative 2, and y to the power of 1 times negative 2 is y to the negative 2. We don't want to leave negative exponents, so I put them under 1. Last example. I want to solve 1 over 3x to the negative 2. Now this is a little bit different because now I have my exponent right here. And so in order to solve this, my negative exponent's on the bottom is what I should have said. But I want to distribute my negative exponent into both the 3 and my x, which would be 1 over 3 to the negative 2, x to the negative 2. Now, here's the thing. If your negative exponent is on the bottom like it is here, in order to make it positive, we have to bring it up here. So switch places with whatever's up here if it's positive or negative. And so this would become 3 squared x squared or 9x squared. So today what we were looking at was the learning targets. I can convert negative exponents to positive exponents. This is what we want, and this is what we're working with. So how would you convert something like this to make it positive?